Hence, there is less hurry and consequently closer attention to detail. Insulator quality begins on the tracing paper. Now, this suspension insulator is an original PINCO design, the work of men skilled in ceramic craftsmanship and schooled in all the problems of fine insulation. PINCO designs require the finest of raw materials. We import our ball clay from Cornwall in England, our china clay from Devonshire. Now, this material is flint from Pennsylvania, and this bin contains Canadian feldspar, the finest grade of quartz rock. Carefully weighed in the correct proportions, the flint and feldspar are ground together in pebble mills. They're so called because they use Japanese grinding pebbles to refine the grain structure. The flint and feldspar discharged through pipes is mixed with the clay. The ball clay, passing through these lawning machines made up of oscillating screens to remove all impurities, the slip passes through the field of a powerful electromagnet to remove metallic particles and is then pumped into filter presses, canvas bags pressed between metal. To prepare the clay for actual insulator production, these discs are placed in a pug mill, in which circular knives refine the clay texture. The clay is extruded in various shapes and sizes depending on the insulator for which it is used. The types are formed in plaster Paris molds. Here the PINCO suspension unit is plunged by a machine operated by skilled workmen. Tamped into this mold with this simple tool, the clay is ready for the plunger. The plunger completes the forming operation. "24 hours later, the suspension disc can be removed. To hand-shape clay properly requires years of experience. For the finishing. PINCO originated and patented this suspension disc can be handled for the finishing operation. Every attention is given to perfect shape and symmetry. Inspection at all stages of the manufacturing process eliminates the possibility of defects. Precision is assured at all stages by the use of standard gauges. Step in the preparation of the clay, and tamping is the next, both of which are followed by the plunging operation of producing the first one-piece, high-voltage, tin-type insulators by plastic process. Hand molding is which brings the clay up in this high-hat shape. A split mold is added to the lower mold and passed down a conveyor to the second machine. A tapered steel rim holds the mold firmly, and a dash of oil prevents the clay from sticking to the heated plunger as it completes the formation of the unit. And now for another PINCO development. Our patented threading process. The thread is rolled into the previously formed hole, shaping the thread with accurate pitch and taper. The completely formed unit, number 1125, rolls down the conveyor ready for the finishing. We have developed automatic machines. This one performs 3 operations simultaneously while the careful fingers of the craftsman lend their touch of artistry to the job. Must be cut accurately. This precision machine does the work with ease. These automatic machines ensure perfect adherence to the design so carefully worked out by our specialized designers. Dried columns of clay are turned on automatic lathes into transformer parts. Some larger shapes made wholly by hand on potter's wheels by a process called jiggering. This process requires considerable handwork, and the operator must be a trained and experienced artisan. Columns of clay direct from the pug mills are formed first by hand and then put into molds. The outer contours of the switch insulator shell are shaped by the mold and the inner surfaces by the hand, guided by a wooden profile. This clay must be worked without introducing distortion or strain lines into the plastic mass. This is a critical operation which we entrust only to employees of long experience. Pipe insulators follow the same routine. Likewise, switch-type insulators. Special machines have been developed for testing smaller units. This test ensures complete uniformity of glazing and speeds up mass production. Kilns receive the glazed insulators. From above, we see a stream of suspension insulators flowing into the kiln. The kilns are fired by men skilled in keeping fires at an even temperature. This flashover is only one of the many tests they receive. A final flashover test is given to ensure the insulator meets the requirements. PINCO product resistance to sudden changes of weather is ascertained by the thermal test. From boiling water to ice water, this test tells us that the sub-zero of early morning can merge into sunlight filled with thick warming rays without a cracked insulator. But ice water is not close enough to the bottom of the thermometer. In this ice box, the insulator requires a soda frost. The chart says 40 below. Design and quality go together. In this design test, we find out what the insulator will do under varying conditions. In dry weather, and with a filmy mantle of rain fluttering down to tax the effectiveness of the insulation. Porosity, diffuse test. Insulators contact with all kinds of moisture, oil, water, even acid. They must be perfectly non-porous. Pressure tanks, broken bits of our porcelain are dropped into a... Thus assembled and crated, the suspension insulators flow in a steady stream onto freight cars, going out to fill the heaviest demands of the transmission lines. Tested for the purpose in our own laboratory. Christmas brought this boy a rifle, but not a target. Ah, here is one.